Good morning, my dear students. Uh, After 1 week, let us start our class on online. Now, in the previous class, we have discussed up to the nuclear fission, isn't it? In that lecture, in detail, we have discussed about what is the nuclear fission, then how the nuclear fission can be explained on the basis of liquid drop model of the nucleus, etc. All those points we have discussed in detail. Now, see, after completion of this small topic, let us come to the next one, the accelerators. Then, what is an accelerator? Accelerator, it is a device which is used to increase the energy of a charged particle. That is, every charged particle, no doubt, it is having some energy. Suppose if we want to increase its energy, then what we have to do? We have to, by using the accelerators, we can increase the energy of the charged particle. Then, in order to increase the charge of it, the energy of the charged particle, whatever the device we are using, that is called as what is the accelerator. Now, there are what is the different types of accelerators are there. Then, in your syllabus, there are two accelerators are mentioned. One is the linear accelerator, another is the cyclotron. Today, we are going to discuss regarding the linear accelerator. Now, before going to discuss regarding its construction, theory, etc., whatever the important points we come across during the discussion of this, that I want to make it clear what is the first. Now, the one is the first one. Yes, you are very familiar that the general formula of the distance, isn't it? Yes, it is equal to OB into T, velocity into time, isn't it? Now, suppose if you wants to maintain time as a constant, the same time, that is when you consider time, it is a constant. This constant mathematically, you will get proportionality here. That is, yes, is directly proportional to the velocity. That is, distance is proportional to the velocity. Now, when it is possible, isn't it? This is possible only when, that is, the distance is directly proportional to the velocity when you maintain time as a constant. Its meaning is that if you want to maintain the constant time, if you want to maintain constant time, if the velocity increases, then it has to travel the more distance, doesn't it? To maintain the same time, if the velocity increases, then it has to travel the more distance. Then only the time will be remains the same. This is the one point. Then the second point is that when any charged particle is what passed through a certain potential difference, when any charged particle passes through a certain potential difference, then it acquires the energy. The amount of energy gained by the charged particle under the potential difference V is what it is the is Q into V. Now, Q is the charge of the particle, V is the applied potential difference. This. The next third point is now the nature of AC is light. Nature of AC is light. Now, this we call it as one cycle. One cycle. Time taken to complete one cycle is the periodic time. Isn't it? Time taken to complete one cycle is the periodic time. Now, when you consider this as a positive, is it a positive cycle, half cycle, it's a negative half cycle. Here, time taken to complete one cycle is what is the T. Next, from here to here, it is equal to how much is the half of periodic time. It is the T by 2. Yes. And remaining T by 2 is this. That is, it shows that then in a half of the period, if it is in the positive direction, in the remaining half of the period, it will be in the negative direction. Isn't it? Means after every half period, polarities will be reversed. Polarities will be reversed. That means for first half period, is it a, if it is in the positive direction, in the remaining half of the period, it will be in the negative direction. Polarities will be reversed. Now, for example, if you consider periodic time as what it is the 2 seconds, example I'm saying 2 seconds. For 1 second, if it is in the positive direction, and the remaining 1 second, it will be in the negative direction. Isn't it? Now, with the help of this one, now let us try to understand in this case. Now, here we are trying as a high frequency oscillator. Isn't it? Then oscillator means what? Oscillator, it is what it is the device which provides the AC of a definite frequency. Isn't it? AC of a definite frequency. Whatever the frequency of AC you want, this oscillator provides that AC of your required frequency. Isn't it? Now, for example, this is the positive and negative. Positive and negative. Now, what will happen is after every half period, polarities will be reversed. Isn't it? For first half, initially, if it is positive, negative, then after a half period, what will happen? This becomes negative, this will become positive. Next, again after what is the half a period, again it becomes positive, negative. Like that, in every regular interval of half of the periodic time, the polarities of this is reversed. Isn't it? Now see these points you remember. Once again, here this what it is the S is equal to distance traveled is equal to velocity into time, and when you take the time as a constant means if the velocity increases to maintain the same time, it has to travel the more distance. Are you this one? The next is this is the formula of the energy gained by the charged particle when it is passed through a certain potential difference V. This one. The next is in case of AC, is it a generator? Then in regular what is the half period, the polarities is what is the reverse. Now these are some of the important points during the discussion of this linear accelerator. Now here, the construction of the linear accelerator is what it is the shown in the figure. All of you be serious here. Now it consists of what is the hollow vacuum tube. It is totally evacuated, in which the number of hollow cylinders of increase in the length are fixed. These are the hollow cylinders which are of increase in the length. You are observing that first cylinder, length of the first cylinder is less than second, then its length is still less. They are go from 1, 2, 3, 4, etc. The lengths are gradually increasing in order. Next, the 1, 3, 5, etc. All odd number of cylinders are connected to one terminal of what is the oscillator. Here you are observing that this 1, 3, next, 5th, etc. All odd number of cylinders are connected to the one terminal, whereas even number of cylinders 2, 4, etc. all are connected to another terminal of what is the oscillator. This is like this. Now this is an electrode. When it is heated, it produces your required charged particle. If you want what is the negative charged particle, you use what is the source of what is the negatively charged particle. Now, what it is when it is heated, it provides the negative charge. That is electron. Now let us consider from here onwards, you should be little bit serious. Now here, let us consider this is a source of negatively charged particle. Negatively charged particle. When it is heated, then it emits the electrons, negatively charged electrons. Here. Now here, at any instant of time, if this terminal is positive, all of you concentrate here. If this terminal is positive, then you know that you are observing that this terminal it is connected to the odd number of cylinders. Means here this is positive, whereas this even numbers negative like this. Isn't it? Now, as soon as the electron is emitted from this what is the source. Now this cylinder it is positive, so that immediately what will happen is the electron which is emitted from here, since it is positive, therefore it gets attracted. Now it gets is what? Its velocity increases means it gains the energy. Now, let us consider here when the electron enters into the first cylinder, its velocity is v1. Isn't it? Its velocity is v1. Then energy gained by the electron when it enters into the first cylinder, it is what it is equal to E1. Let us consider half m v1 square. V1 is what? It is the velocity of the electron in the first tube. This. Now, this is the what? It is the energy of the what? It is the electron in the first tube. Next, if the apparent potential difference from this oscillator is V, then this will also be equal to the formula is what? Then Q into V, charge into the potential. Now, see, this is the energy of the particle in terms of mass and velocity, and this is the energy of the same particle in terms of charge and potential difference. Now, see, from this equation, what you get it here, you cross multiply, then V1 square, it is equal to, what you get it here, V1 square is equal to, it is 2QV divided by, you will get it here, yeah. Isn't it? Therefore, V1 it is equal to square root of this one. That is 2QV divided by what? Yeah, this is a capital V means potential difference. That is. Now, let us represent this equation number as 1. Isn't it? Then once again repeat here. This what is the source? It is heated. Let us consider it emits the electrons, negative charge. Any instant of time, this terminal is positive means this cylinder is positive, so that electron is negative, it gets attracted. When it gets attracted, its speed increases so that it gains the energy. Let us consider the what is the velocity of the electron when it enters into the first tube is V1. Then the energy of the electron in the first tube, it is equal to half m V1 square kinetic energy. It is equal to what is the Q into V, that is the charge and the applied potential. Now, from this, when you simplify this one, you will get V1 is equal to this. Okay. Next, what will happen is, as soon as it enters into the first tube, then this is the point, this is the only point to understand. Afterwards, remaining you can understand very easily. Now, as soon as it enters into the first what is the tube, then is it has to travel. Isn't it? The first one is the Q. Then here, time taken by the electron to travel the first tube is adjusted such that it is equal to half of the period of AC. Isn't it? That means to travel the electron through this first tube, it will take what is some time. Then that AC is adjusted that the time taken by the electron to travel the length of the first tube, it is equal to half of the period of AC. Isn't it? That means, as soon as the electron comes out from this first tube, isn't it? Time taken equal to half of the period, then immediately the polarities will be reversed. Means, earlier it was negative, after completion of the half period, then it becomes as positive, this is negative, this is negative. Therefore, as soon as it becomes polarity, now it has become as a positive. So that what is the attracted towards the second cylinder. Then when it is attracted towards the second cylinder means again the speed what is the increases. Now let us consider when the electron enters into the second cylinder, its velocity is V2. Isn't it? Then the energy of the electron in the second cylinder, is it E2? It is equal to half m of V2 square. This is equal to, isn't it? This is in terms of mass and velocity, and in terms of potential difference is what you get me. When it is attracted, is it once? Then it is QB. Now it is attracted second time, isn't it? Twice. So that the energy will be equal to 2 what is the Q into V. Because it is when it is entering into the second cylinder, it is attracted second time. Why? So that it is 2QV. Now, when you simplify this one, then from this equation V2 square, it is equal to, now you take it here, this is 2 into 2QV divided by M. Isn't it? Therefore, and V2 is equal to under root of this one, then here you get 2 into or 2QV divided by M. Isn't it? Now, the same equation, you can write it as how it is. First, you write root 2 like this one. Isn't it? Remaining is again you write as what it is the take out this one, then you can write 2QV divided by M. Now, this is equal to, you can see that the this is equal to V2. It is equal to root 2, you write as it is. Now, you can see that this complete, it is equal to what is the V1. Isn't it? Therefore, this is equal to V1. Let us represent this equation number as what is the 2. That means it shows that the velocity of the electron in the second tube, it is equal to root 2 times the velocity of the first one. Then here you are observing that the length of the second tube, it is more than the length of the first one. Why? You are already very clear that when the electron is entering from first cylinder to the second cylinder, is it? Its velocity increases. Is it? Then I have very clear that as the velocity increases, to maintain the same time, it has to travel the more distance. That is, when the velocity increases, to maintain the same time, it has to travel the more distance. Isn't it? So that the electron, when it is entering into the second cylinder, its velocity increases. Therefore, to maintain the same time, it has to travel the larger distance. Isn't it? So that the length of the second tube is more than the length of the first one. Again, just here the electron comes out from the second cylinder, the time is same, equal to how much it is the half of the period. Again, the polarities will be reversed. Polarities will be reversed, which means what? Earlier it was negative, now it becomes as positive. Has come out. Then this is the negatively charged electron. Now it has become what is the positive. Now again it gets attracted. Isn't it? Then again it gets attracted means what? Then its velocity increases again. Isn't it? Therefore, if you consider when the electron enters into the third tube, its velocity is what is the V3. Then energy of the electron in the third tube, it is equal to half m V3 square. It is equal to how much we get when the electron is entering in the third tube. It is attracted. What is the thrice? Thrice gets attracted. Isn't it? So that here you will get 3Q into V. Now, after simplification of this one, you can see that V3 square, it is equal to, then this is, you will get 2 into 3QV divided by what? M, isn't it? And this V3, it is equal to, you take under root. Now itself I will write, when you take the under root, I can write this as root 3 into what is the root of 2QV divided by M. This is right. Now, you can see that this is equal to root 3. This complete, it is equal to what it is the V1. Now, this is the V2. Now, see, this is the, what it is the second equation and this is the third equation. Looking to the equations, what it is the 1, 2 and 3, then you can understand that here V1 is to V2 is to V3 and so on. It is equal to how much it is? It is equal to, here, this is what V1, V2 is equal to root 2 times V1. Then V3 is equal to root 3 times what is the V1. So that V1 is to V2 is to V3, it is equal to 1 is to root 2, it is to root 3 and so on. This is what we did here. isn't it? Therefore, this is the way in which the velocities are increasing, isn't it? Why entering from first to second, third to fourth, etc. Yeah, velocities are increasing, isn't it? Then to maintain the same time, they have to travel the more distance, so that the lengths are gradually increasing, isn't it? This one. Now the question is that if the lengths are gradually increasing in order means, then increasing means in at what rate they must be increasing, isn't it? Then you cannot take any what it is the rate of increasing. Is it? I mean to say that suppose if it is a 5, then can you take 10? Isn't it? Or 15 like that increasing. If it is 5 and 10, 15, can you take it? Then no. See, you cannot take what randomly. You see, then for that you must calculate that at what rate the lengths of the two should be gradually increased. Isn't it? That means if the length of the first one is some value, then what should be the length of the second sheet more than the first one? But more means how much it is. Practically, you have to calculate and you have to put that much length. Similarly, what should be the length of the third? Isn't it? Then what should be length of the fourth? Isn't it? You have to calculate, isn't it? What are the lengths of the first tube, second tube, third tube? In that order only, you have to go on increase the length. Now let us find, isn't it? What should be the lengths of the first tube, second tube, third tube, etc. Then here, for calculation of that, then we use this relation. Isn't it? Now here we have what it is shown that the velocities, isn't it? V1 is to V2 is to V3, and so it is equal to 1 is to root 2 is to root 3, isn't it? And so on, isn't it? Now, if you consider this is the first tube of length L1, second tube of length L2, and third tube of length L3 and L4, etc. What should be the length of this L1, L2, L3, L4? Then you have to calculate it, isn't it? Now first, the distance formula is what? Velocity into time. In this case, time is a constant. Time equal to how much it is? It is equal to half of the period of AC. When you take out what is the constant time, you will get proportionality. Isn't it? Yes, is directly proportional to B. This is a relation already what I have written to you. Isn't it? For your understanding. Now, this is the distance. Distance is nothing but we take it here as a length. Isn't it? Now, if you take here L1, isn't it? L1 distance will travel with the velocity V1. Therefore, L1 is directly proportional to V1. Isn't it? Then next L2 is proportional to V2. Isn't it? And L3 is proportional to V3. Isn't it? Therefore, because the distance is proportional to the velocity. Isn't it? Here, distance is nothing but length of the tube. Okay. Now L1 is directly proportional. Distance is proportional to the velocity means here. Therefore, L1 proportional to V1 because V1 is the velocity in the length. What is L1 and L2 is proportional to this. L3 is proportional to this one. Now mathematically you can write as what means here L1 if you are directly proportional you can write L1 is to L2 is to L3 is to and so on is equal to what you get it here is equal to V1 is to V2 is to V3 and so on. Okay. Therefore, this is what the relation. Okay. Now here you have to know that V1 is to V2 is to V3. They are in the ratio of what? 1 is to root 2 is to root 3 and so on. That means here the length of the tubes are in this ratio. That is L1 is to L2 is to L3. It is equal to 1 is to root 2 is to root 3 etc. Now, when you arrange the lengths of the first tube, second tube, third tube, etc., in this order, then only what will happen is the time taken by the electron to travel in all these lengths will be remain the same. That is equal to the half of the period of AC. Then only in a regular interval of half of the period of AC, the polarities will be what is the reversed. The other result, the particle is gradually what is the attracted means velocity increases, hence its energy also gradually increasing. Isn't it? Now for what you are understanding, let us take an example. Isn't it? Now for example, here I think how many of you have understood? I don't know it is the lengths or it is in this what is the order, that means L1 is to L2 is to L3 is equal to 1 is to root 2 is to root 3. It's actually that you must understand, because now you are not a small, what it is the children of lower classes, now you are in by BSc final year, isn't it? Then if the lengths are in this order, L1 is to L2 is to L3 is equal to 1 is to root 2 is to root 3 etc. means, then what actually meaning is, isn't it? And some of the students still might not have got the idea. For those students, let us take an example. Isn't it? Now we have our understanding this. Let us consider L1 is equal to 10 centimeters. Isn't it? 10 centimeters. Then what should be the length of L2? Isn't it? L2 is equal to root 2 times what is the L1? Isn't it? Root 2 times. Isn't it? Because here L1 is 1, L2 is equal to root 2 times. Now, to here root 2 value equal to how much? Then you know that 1.41, isn't it? 1.41 into L1 is how much? It is the 10 centimeter. That is equal to, you will get it here, 14.1 centimeter. L2. Isn't it? Next, it is equal to how much? Isn't it? L3 is equal to root 3. Is it times of what is the L1? Isn't it? Then now this is equal to here root 3 times of L1. It is nothing but root 3 is 1.717 into 10. That is equal to 17.17 centimeter. Isn't it? This is the value of what is the this L3. Isn't it? Now here you can see that if L1, that means it is the first, is it a cylinder of length 10 centimeter, then second, what is the cylinder should be of 14 centimeter, then third is of 17.17 centimeter. Then in this way you go on arrange the cylinders, then what will happen is, isn't it, after passing through each and every length of the tube, polarities will be reversed. Therefore, gradually they will be attracted. Isn't it? Yes, continuously they are attracted. Therefore, they will, what is the, gets increasing energy. That means, yes, it is what is the attracted from one by one. Gradually, they gains the more and more what is the energy. In this way, we can increase the energy of the what is the charged particle after passing through such a what is the tubes. Isn't it? Now, the question, isn't it, arises that, is it, seriously listen here, all of you. Now, therefore, this is the way, isn't it, in which, isn't it, length of the tubes must be arranged. You might have understood that if the length of the first tube is 10 centimeter, then length of the second must be equal to 14.1 centimeter. Then third is 17.1 centimeter. Let you go on arrange them, then the electron or any charged particle, after passing through such a tube, its energy gradually increases. Isn't it? Now, the last point to understand is that when we see this here, no doubt as it passes from one tube to the another tube, its energy gradually increasing this what? To get the what is the definite amount of energy of the particle, isn't it? Serious reason here, all of you. To get a definite energy of the charged particle, isn't it? Then through how many tubes it has to be passed through? That's the very important. As it passes through more number of tubes, it gets a more and more amount of energy. Then to gain a definite amount of energy, then it has to pass through a definite number of tubes. Did it? 10, 20, 30 like that. Then how to what is the get an idea? Isn't it? Now that you can calculate it. Now let us consider the maximum energy required. Maximum energy required En is equal to En. Isn't it? Then here to get this much amount of energy, then we need that through how many number of tubes it has to pass through. Isn't it? Then yes, you know that first if the charged particle attracts by what is the one tube, it gets the energy equal to QV. Second tube 2 QV. Third tube 3 QV. Like that. Let us consider to get the maximum amount of energy N, it has to pass through N number of tubes. Isn't it? Then the energy gained it is equal to N into QV. Isn't it? Where N is what? It is the number of tubes through which the charged particle must pass through to get a certain maximum amount of energy. Isn't it? Now, from this one, you will get the value of N. This N, it is equal to En divided by what is the Q into V. Then all the values are known to you. Substitute what these values in this equation you will get. Then how many number of tubes the charged particle has to pass through it. Because through how much amount of maximum energy required. Let us take an example of what it is the 100 million electron volts of energy required. Isn't it? We need a charged particle of energy how much? 100 million electron volts. This much energy. You put it here. Then for our understanding, let us consider charge of the particle is equal to 2 coulombs. Isn't it? It is a different, but for our understanding, it's 2 coulombs. And energy or applied potential difference, isn't it? From this, what is the oscillator? Isn't it? That means signal generator. All of you have used it in the practicals. Isn't it? Signal generator. That is nothing but it is an oscillator. Same time. Then applied potential difference V, let us take it as equal to 5. Isn't it? Then Q value is 2 coulombs, applied potential difference is 5, maximum energy required how much it is the 100, isn't it? Now you can see that then 5 to the 10, isn't it? 1 will get cancelled with this one, isn't it? 100 divided by 10, that means this is equal to 10, isn't it? Therefore, here in order to get this much amount of energy, 100 million electron volts, isn't it? Then it has to pass through how many? It is the 10 tubes it has to pass through. Isn't it? Like you are in here. For example, if you take length, first tube of length 10 centimeter, then second tube should be 14, third tube should be what it is 17. Similarly, you calculate L4, it is equal to root 4 times L1. Root 4 means what? It is 2 into L1. That is nothing but it is what it is the 2 into 10, that is equal to 20. Like that, you calculate this, what it is you require the 10 tubes means, then select the first tube of length. Then you calculate second, third, fourth, fifth, fifth, etc. up to 10. Then you arrange them all those what are 10 tubes is it in this order. Then if the charge is equal to this much, you apply the voltage of 5 volts. Then we require 10 volts means 10 tubes means after passing through what that charged particle through 10 tubes, then it requires energy equal to 100 million electrons. Now see, this is the way how you can calculate it. I think all of you might have understood, isn't it? This, what is the point, that is the linear accelerator. I hope all of you have understood this one. Now I will stop here. Then the next, what are the limitations or drawback of this linear accelerator? How, what are those drawbacks can be overcome? All those points we'll discuss in the next class. Thank you, one and all. Now I stop here.